This is the second part of the video on the inverse trigonometric functions. So in the previous course you learned that if you compose a function with its inverse function, you always get back to the original input you started with. So basically the input goes into the inverse function, and then we take that output and put it into the original function, and we get the input back. Same thing here, we put the input into the original function, get an output, and then put that output into the inverse function. And again, inverse functions undo the original function, what the original function did to the input, so we get back to the original input. So that's what happens with inverse functions typically. So again, if you have a line y equals 6 plus 3x, and you have another line y equals x minus 3 all over 6, and if you put this function into this function where the x is, you get 6x plus 3 minus 3 over 6, which ends up as 6x over 6, which ends up as just x. So we put one function into the other and got x. And then if we reverse the order, meaning that we put all of this one in for that x, we get 6 times x minus 3 over 6 plus 3. Alright, the 6's cancel. I'm left with x minus 3 plus 3, which is also x. So that's the way it worked with inverse functions in the previous course. Alright, and in this course it's going to work that way sometimes. Alright, but other times we'll have to do a lot of thinking to be able to get the correct output. Alright, now what this is saying is, if we plug in a a value into the inverse sine function, inverse cosine, inverse tangent function, and then plug that into the same trigonometric function, all right, the regular version, we get back to the original, as long as that original x is in this interval, as long as that x is in this interval. Okay, so in this case, the sine, we got one that looks like this. The sine of pi over 4, you can either do it just looking at this and say, alright, well that's just going to be pi over 4, alright, because pi over 4 is within that interval. But you can also say, well, sine of pi over 4 is the square root of 2 over 2. And now we're dealing with the arc sine of the square root of 2 over 2. Alright, well, again, bring back your unit circle. And remember, for arc sine, we have to be in quadrant 1 or quadrant 4. Alright, for arc sine, arc tangent, we're here. For arc cosine, we're in quadrant 1 and 2. Alright, and you ask yourself, where in these two quadrants is the sine, the y coordinate, the square root of 2 over 2? And right here it is. So the arc sine of square root of 2 over 2 is that angle, pi over 4. Alright, and the same thing with the cosine. The cosine of 2 pi over 3. Right, now 2 pi over 3, is that within 0 to pi? Yes. So because that is within 0 to pi, we're just going to get back to x. Okay, but again, I always want you guys to think through these with the unit circle. You can use just the inverse property because it is true, but only because we are within the domain right here. We're within the original interval. Alright, so the cosine of 2 pi over 3 is the x coordinate, so that's negative a half. Alright, so we start off with the arc cosine of negative a half, and then you ask yourself, where within 0 to pi is the arc cosine equal to negative a half? So we can see within quadrants 1 and 2, because again this is cosine now, so we're dealing with quadrant 1 and quadrant 2. That's where arc cosine is defined. Remember, we had to restrict the sine and cosine tangent functions because of the repetition. We had to restrict those to be able to have these things be functions, for there only to be one output and be a function. So within these two, where do I get negative a half for cosine? I get it right there in quadrant 2 at 2 pi over 3. So it is again a case where we get back to the original. Alright, it's only because this was within the original interval that we were dealing with. Okay, we're going to see some later on where the original number here and the number we get out is not exactly the same. Okay, and that's where we're going to have to kind of differ a little bit from what we learned in the previous course. Okay, it's not always going to be true for every single arc trig function, the final output. Alright, and then right here, negative pi over 6, that's also within the interval, negative pi over 2 to positive pi over 2. So right here we're going to get right back to x. We're going to get back to the negative pi over 6. Again, I want you to practice it on the unit circle though. Alright, so I got the unit circle here. The tangent of negative pi over 6 here. Remember, this is pi over 6, so this would be negative pi over 6. So this is the tangent of negative pi over 6. This is not as steep as this. Okay, this is not as steep as this, so this one's going to be, for tangent, this one's going to be the negative 1 over the square root of 3 or the negative square root of 3 over 3. However you want to write it. So we end up with the arctangent of the negative square root of 3 over 3, or negative 1 over the square root of 3. Alright, and then because we're dealing with arctangent, we're restricted to quadrants 1 and 4. Alright, this is the only place that we can end up because of the redefinition of the domain of tangent to be able to create an arctangent function. We have to be in one of these two quadrants. We can't be in the others. So in these two quadrants, where is the slope, where is the tangent equal to this? Okay, and which of these two quadrants do I see the tangent equal to this? Well, it's the one we just came up with. Again, this was in the original domain, so it's got to be negative pi over 6. Okay, now it's not equal to 11 pi over 6, even though that's what it says on the unit circle. It's because when we define arctangent, it's from negative pi over 2 down here. Even again, that's 3 pi over 2 on this unit circle. It's defined, arctangent's defined from negative pi over 2 to positive pi over 2 because we want the smallest angles in absolute value that could cover the entire gauntlet of the tangents output. And the closest we could get and do that was negative pi over 2 to positive pi over 2. So even though the unit circle shows these angles in radian measure, the arctangent is going to spit out these negative versions of these angles, the negative coterminal versions of the angles, as the actual numbers, no matter what this original number in here was. Okay, so you got to be careful with this. Alright, but when this original number is within the domain of the arctangent, I'm sorry, the range of the arctangent, the original input of the tangent is in the domain of the arctangent. Sorry, the range of the arctangent, I said it wrong again. You'll always just get back to what you started with, okay? But we're not always going to get back to what we started with, is my point. So I want you to see how we're going to have to think through this and the upcoming problems. So here we go, and this is one where we got to be careful if these arc trig functions are on the outside. If the arc trig functions are outside and the inner function is not within these intervals, now we have to do a little bit of work. Alright, we're going to have to really think through these. Alright, so the sine of 5 pi over 4. So what's the sine of 5 pi over 4? Well, here is 5 pi over 4. The sine is the y-coordinate. So the negative square root of 2 over 2. So the sine of 5 pi over 4 is negative square root of 2 over 2. So I have so far the arc sine of negative square root of 2 over 2. Okay. Now, 5 pi over 4 is down here in quadrant 3. Arc sine is only defined in quadrants 1 and 4. And in quadrant 4, we're dealing with negative angles. We're dealing with negative pi over 2, negative pi over 3, negative pi over 4, negative pi over 6. Alright, because we're going this way down into quadrant 4. We're going up this way into quadrant 1. So pi over 6, negative pi over 6, pi over 4, negative pi over 4. Alright, that's how arctangent and arcsine are both defined. So in these two quadrants, where do I see this number? Where do I see this for the y-coordinate? So there it is. It's got that as its y-coordinate. Well, what angle is this? This arcsine is going to spit out negative pi over 4. Okay, it does not get me back to what I originally started with. Why? Because what I originally started with was not in quadrant 1 or 4. It's in quadrant 3, like we said. So what I have to do is find something that has the exact same y-coordinate, right, as this, but it's in the quadrant that I want to get to. So to get to the same y-coordinate, you just go horizontal parallel to the x-axis until you touch the unit circle again and get yourselves into the correct quadrant. The correct quadrant meaning the quadrant that you're supposed to be in, that the arc trig function is defined in. And this arc trig function is defined in these two. So I need to go from 3 horizontal over to 4. Again, why am I going horizontal? To preserve the y-coordinate. Everything on that horizontal line has the negative square root of 2 over 2 as its y-coordinate. So this point over here will as well. That has this angle, but this negative angle. And it's important that we get the negative angle right because that's how arctangent is defined. Alright, so cosine of the arc cosine of 1.5. Okay, now, what goes into arc cosine? What do we put into these arc trig functions? We put in outputs of sine and cosine. Okay, that's what goes into arc cosine. So an output of sine or output of cosine to go into the arc cosine would be this 1.5. Well, what's the problem here? We're trying to ask ourselves to be able to do this. We have to ask ourselves the cosine of what number is equal to 1.5. Right? Well, that doesn't make any sense because the highest that cosine could be, remember, because cosine are the x coordinates on the unit circle, and the highest that cosine could be is 1 at an angle of 0 or 2 pi. That's the biggest x coordinate that we see. So cosine can never be 1.5 because we're not even on the unit circle anymore. Alright, so that's impossible. So we can't do this. So we can't do this problem at all. There is no such arc cosine output of that input. There is no way I can put that into the cosine function. That's out of the interval, negative 1 to 1 here. Alright, the arctangent of the tangent of 4 pi over 3. Alright, now we'd get back to x if 4 pi over 3 were in this interval, but again 4 pi over 3 is bigger than pi over 2. So that doesn't mean there's not a real number like it did here. Okay, this is there's no way I can put anything into the cosine. I can put 4 pi over 3 into the tangent function. It is in the domain of the tangent function. it just isn't going to get me right back to what I started with. So it's going to be something similar to this. Alright, so first of all, let's find 4 pi over 3 and figure out what the tangent is there. So here is 4 pi over 3. Alright, we're moving uphill left to right as we make our way left to right. So that is a positive value, and it's on this same line right here as pi over 3. It's on that same line, and remember this one, the slope was square root of 3. So if that's the slope of this line segment, and that line segment is connected to this line segment, and they run together to form the exact same slope, that means that this value right here is also 4 pi over 3, square root of 3. Alright, now arctangent of the square root of 3. Arctangent is only defined in quadrants 1 and 4. Alright, for arctangent, arcsine, it's 1 and 4. For arc cosine, it's 1 and 2. And so I ask myself, where do I see a slope, or where do I see a tangent of the square root of 3 in these two yellow regions in quadrants 1 and 2? Well, I see it right here, where that line connected to it. Alright, and what angle is that? That's pi over 3. So the arctangent of the tangent of 4 pi over 3 is 1 pi over 3. Alright, so it's very similar to the sine one that we just saw, in that the original angle and the angle that we ultimately ended up with was not the same thing. And it's because of the fact that these original angles that we were given, the 5 pi over 4 was not in this interval. The 4 pi over 3 was not in this interval. When that happens, we are going to have to make our way back in to these intervals, negative pi over 2 to positive pi over 2, to be able to find out what the equivalent output of the arctangent would be. This goes back to the fact that arcsine and arctangent only give acute angles. 4 pi over 3 is not an acute angle. 5 pi over 4 is not an acute angle. So because they're only given acute angles, there's going to be some type of a difference when we do an arctangent of the sine or tangent of a obtuse or even beyond obtuse angle. Okay, so arc cosine a little bit different. It does allow obtuse angles, okay, but it doesn't allow for negative angles, and it doesn't even negative acute angles, and it doesn't allow for angles bigger than 180 degrees or pi radians. All right, now for the really fun stuff. Notice with these we have two trigonometric functions, one regular, one inverse, but they're not the same. So we can't use this type of stuff because it's not tangent arctangent, cosine arccosine. It's cosine arctangent. So what do? Well, what you have to think of is, remember that the arc trig functions, all they are just angles. So think of that as just theta. Okay, so theta, the angle that we're dealing with here, is the arctangent. Remember, arc, trig just mean angle. So the arctangent of 5/12. Well, remember this property, the tangent of the arctangent, as long as this number that's going into the arctangent, as long as that number that's going into the arctangent is a real number, then we just get right back to x. So this is a real number, so the tangent of the arctangent of 5/12 is just 5/12. So the tangent of theta is equal to 5/12. Okay, well, what does that mean? Well, with right triangle trig, there's theta, there's a right angle. Remember, tangent is opposite over adjacent. So the opposite side of the angle is over here, and we're saying that that's 5, and the adjacent side of the angle is the side that forms the angle that's not the hypotenuse, so the adjacent is right here, and that's 12. So using the Pythagorean theorem, we can figure this third side, and this is the hypotenuse. Alright, it's 13. That's a Pythagorean triple. I just got that memorized. If you don't have that memorized, then just square this, add them, take the square root, and you'll get 144, 25 is 169, the square root is 13. So there's the hypotenuse. Okay, well, why does that matter? Well, there's the angle right there. There's the angle that we're talking about right here. So what's the cosine of that angle? Well, the cosine of the angle is the cosine of any right triangle's angle is the adjacent over the hypotenuse. Koa and SOHCAHTOA, or sorry, Ka on SOHCAHTOA. The adjacent side is 12, the hypotenuse is 13, so the cosine is 12/13. Alright, I can check this on my calculator. Let me back out the cosine of the arctangent of 5/12 is that number, and I said that that's 12/13. Alright, so they are the same. Alright, so there's the process. We treat this as an angle. The arctrigs are angles, and then we use the inverse property of the tangent of the arctangent, the sine of the arcsine, and get just this number over here, and then set up my right triangle. Alright, cotangent of the arcsine. Same thing here. This is my angle. This is the theta. All of this. So theta equals the arcsine of -1/3. Well, if I take the sine of both sides of that equation, these two wipe each other out. Alright, sine, arcsine. So I'm left with the sine of the angle is equal to -1/3. So now I'm going to set up my right triangle. Alright. The arcsine of -1/3. Remember, negative and arcsine. If you're dealing with arcsine, you're either in quadrant 1 or quadrant 4. Alright, so because it's negative, I'm going to be down in quadrant 4. And the sine is -1/3. Remember, this is, for sine, this is opposite over hypotenuse. So the opposite side, my angle is going to be like this. So the opposite has to be 1, and the hypotenuse has to be 3, right? And technically that opposite is -1. So we can find this with the Pythagorean theorem. 3 squared is 9. 1 squared is 1, or -1 squared is 1. So this is 3. Because we're finding a leg, right here's my right angle. This is the hypotenuse. So because we're finding a leg, it's 9 minus 1. So 9 minus 1 is 8. So that would be 2 square root of 2. The square root of 8 is 2 square root of 2. Alright, so there's that third side. Why do I need that third side? Because this is now cotangent. Okay, cotangent. And what's cotangent defined to be? Cotangent is the reciprocal of tangent. Tangent's opposite over adjacent. So cotangent is adjacent over opposite. Alright, the adjacent side is the side that is touches the angle that's not the hypotenuse. So there's the adjacent side. Alright, and the opposite side is the one that we came up with before, which is just -1. That was the opposite. Okay, we saw that before. So the cotangent of the angle is equal to adjacent, which is the square root of 2, or sorry, 2 times the square root of 2, divided by the opposite, which is -1, which means the cotangent is just the -2 square root of 2. Alright, now how would I check that on my calculator? A little bit trickier this time. Alright, we've got an arcsine, but we have a cotangent. So remember, that's tangent reciprocal, so we use tangent. and then we use the arc sine of -1/3. Close that off. That closed off the arc sine. Close off the tangent, right? And because it's cotangent and not tangent, we need the -1 there. Alright, so we hit enter, we get that -2.828. So we'll do -2 times the square root of 2. Alright, we get the same thing. Alright, so anyway, tangent is the reciprocal arc of cotangent. So when you close off tangent, you'll hit that -1 button. That's not the same as tangent -1 arctangent. Tangent to the -1 power, once you've closed it off, is the cotangent. Alright, now, if x is a number between 0 and 1, we want to write the cosine of the arc cosine of x as an algebraic expression. Now we're going a little bit even further with this, to where we can figure out what it's, what a formula would be for any number that goes in. Alright, so it's kind of like we're setting up the right triangle. We're still going to set up the right triangle and do the same stuff. It's just we have an x in here rather than a number, right? We'll still do this. We'll still set up our trig function and come up with an expression. It's just a little trickier because it's just a variable rather than a number. Alright, so the cosine of the arc sine. So same thing as before. My angle is the arc sine of x. So the sine of my angle is the sine of the arc sine of x. X is between 0 and 1. That's in the domain of the arc sine. So we'll end up with just x. Okay. Now, to be able to set this up, remember, to do the right triangle, I need opposite over hypotenuse. That's what sine is defined to be. So I'll just put this x over a 1. Anything divided by 1 is itself. And now I have the opposite side is x, the hypotenuse is 1. So I'll set up my right triangle. There's my theta that I'm dealing with here. And the opposite is x, so the opposite side of that angle is x. There's the 90 degrees, so that means the 1, the hypotenuse, is opposite the 90 degrees. Alright, so what does this end up being? Alright, I need this because it's the adjacent side, which is needed for cosine. So I do the Pythagorean Theorem. 1 squared minus x squared equals, call it b squared. Alright, take the square root of both sides. Square root of 1 minus x squared is b. Like a squared plus b squared equals c squared. So b is the square root of 1 minus x squared. Alright, now label them if you want to, if you need to. This forms the angle with the hypotenuse. This is the hypotenuse. It's opposite the 90 degrees. This forms the angle with the hypotenuse, so this is the adjacent side of the angle. And that means this is opposite of the angle, so this is opposite. And what do I need for cosine? I need adjacent over hypotenuse. So for cosine, I need adjacent, the square root of 1 minus x squared over the hypotenuse. The hypotenuse is 1. So the cosine of the angle is just the square root of 1 minus x squared. Alright, so if we had a number, any number in here between 0 and 1, like a half, so this would be the square root of 1 minus 1/2 squared. We would just plug it in and that would be what the cosine would be. Alright, now the only difference here is if this had been negative, if we're saying it's positive, it's the positive version. If it had been negative, this number right here, the arc sine, whatever, we would have had a negative value, right? Let's see, right here we'd have had a negative for this, but it doesn't matter because if this were negative, if we had a negative angle, quadrant 1 and 4, cosine is positive in both of those two regions. You know, here's where arc sine is defined. Arc sine is defined in quadrant 1. It's also defined in quadrant 4. Well, in quadrants 1 and 4, you see, remember, cosine is the x-coordinate. And since cosine is the x-coordinate's positive in those two regions no matter what. So in these two regions, the cosine's positive. We don't ever have to worry about it. Alright, positive x's here going into the arctangent. And then we're going to take the secant of that. We're going to do the same thing we did before. So theta is the arctangent of x. So that means the tangent of theta equals x. Alright, and we're going to do the same thing. We're going to write it as x over 1. Tangent is opposite over adjacent. So when we set up our right triangle this time, there's theta, there's the 90 degrees. This is the opposite side, right, opposite the angle. This is the hypotenuse. So that means this is the adjacent side. So opposite is x. The adjacent side is 1. So we can do some Pythagorean theorem to come up with the hypotenuse. So x squared plus 1 squared equals c squared. A squared plus b squared equals c squared. So that's x squared plus 1. Alright, and then to get c by itself, we just take the square root. So that's our hypotenuse, the square root of x squared plus 1. Alright, now what do we need? We need the secant of this angle. There's our angle. We want the secant. This is all just the same as the angle. So we want the secant of that angle. What's the secant defined to be? It's the reciprocal of cosine, and the cosine is adjacent over hypotenuse. So the secant is the hypotenuse over the adjacent. Alright, what's the hypotenuse? The hypotenuse is the square root of x squared plus 1 divided by the adjacent side was 1. So the secant of that angle is equal to just the square root of x squared plus 1. Alright, now pick a number. Let's say x is a number bigger than 1. It doesn't matter. So let's say x is 3. So the secant, remember, that's the reciprocal of cosine of the arctangent of 3. We're saying x is 3 just to try this out, see if it works. Alright, close that off. That closed off the arctangent. Close that off. That closed off the cosine. We need a -1 to make it secant. Hit enter. We get this number. Alright, now we're plugging in 3 for x. So the square root of 3 squared plus 1. And we get the same thing. So this will work for any number that we pick for x in the beginning and the end. Alright, plugging that number in for x in the beginning, plugging that number in for x in the end, we get the same thing. Alright, now we got an uglier one here, but we don't do anything different. The math is the same. So all of this is our angle. So theta equals the arc sine of all that stuff. That means the sine of the angle then is equal to all that stuff. Sine is opposite over hypotenuse. So when we set up our right triangle, there's my angle. Alright, the opposite side of that angle is x. The hypotenuse is the square root of x squared plus 4. Alright, and now I need to solve for this side. Again, I was calling it b squared before. So the square root of x squared plus 4 squared minus, because we're solving for a leg rather than the hypotenuse, minus x squared equals b squared, equals some leg. Alright, squaring the square root, we'll get rid of the square root. Minus x squared equals b squared. Alright, the x squareds cancel, so we get b squared equals 4. So b is plus or minus 2. This would matter if we had a, if we were told which quadrant we were in or something like that, but because we're not, and because we're dealing with x here with a variable, we could, the x will gobble up the sign, whatever x is will determine that sign. So we're going to take those plus or minuses away and just use the 2, and then let the x determine the sign. Alright, so b equals 2. Since b equals 2, we know we have this. Now this is opposite. The 2 is the adjacent. The square root of x squared plus 4 is the hypotenuse. And we want secant. Secant is the reciprocal of cosine. So that's hypotenuse over adjacent. Again, the hypotenuse is this expression. The adjacent side is 2. So there's our secant. Alright, again, pick a random x. It doesn't matter what you pick to check, as long as it's in the, this will be in the domain of arcsine because of just the way it's written. But secant, again, that's reciprocal of cosine. I'm going to use arcsine. I'm going to pick, again, it doesn't matter, 5 divided by the square root of 5 squared plus 4. Close that. That closes the square root. Close that. That closes the arcsine. Close that. That closes the cosine. And then we need a -1 to make it secant. So there's what we get if I plug into this in the beginning or the end. The square root of, I said 5, so 5 squared plus 4. Close that. That closes out the numerator divided by 2. Alright, again, we get the same thing. So you can check these things at the end. Just make sure to plug in the same thing for x in the original that you plug in at the bottom.